Hi, welcome to section 10.1, Radical Expressions and Graphs. Hopefully by the end of this, you all will be able to determine if a root is rational, irrational, or imaginary. You'll be able to evaluate radical expressions and graph radical functions. So let's talk about some vocabulary. When I talk about a rational number, that is a number that can be written as a fraction. So integer over integer. In simplest form, that's a rational number. So 2 over 3 or 4 over 1, or even negative numbers like negative 16 over 3. Those are rational numbers. An irrational number is a number that cannot be written as a fraction. Generally, if you look at the decimal places, they are going to keep going forever, and they don't have a pattern to them, okay? The square root of a positive number is always going to be a real number. The square root of a negative number is going to be an imaginary or a not real number. So, we're going to go ahead and do our first example. We're going to determine if each square root is rational, irrational, or not real. And we're going to find each square root. Okay, if it's rational, we'll answer as an integer or as a fraction. If it's irrational, we'll give an approximation to the nearest thousandth using a calculator. So, first one I've got for us is the square root of 169. All right, so you guys are going to have a strange knowledge of perfect squares and cubes and even fourth powers probably by the end of this unit. But the 169, that's 13 squared. So you may know 13 squared is 169. So that means that the square root of 169 is 13. Okay? 13, it's a nice pretty number. It can be written as a fraction. It can be written as 13 over 1. So that is rational. Okay? It's a perfect square. All right, next one I have is the square root of negative 49. All right, when you have the negative inside of a square root, that's going to give you an imaginary or a not real number. So we're going to say it's not real. And in case you're wondering, you're like, well, but, 49, that's 7 squared. I hear you. So just reminding you guys, 7 times 7 is positive 49. If you had negative 7 squared, negative 7 times negative 7, you would still get 49, positive 49. So any two numbers multiplied by itself, a positive times a positive or a negative times a negative, you're going to get a positive answer, not a negative answer. And that's why these square roots of negatives give us a not real or an imaginary solution. All right, next one has the negative on the outside, which is perfectly fine. That just means that we're going to get a negative value at the end. 61 is not a perfect square, though. 49 is a perfect square. That's 7 squared. 8 squared is 64. But 61, it's between those two. So we're going to get somewhere between 7 and 8. So if you type it into your calculator, you just put in the square root of 61. You're going to get about 7.810. I'm doing 3 decimal places because it did say to round to the nearest thousandth place, and that's 3 decimal places. With that negative, it just means that our answer is negative because that's out front. So our answer will be negative as well. This one, it wasn't a perfect square, so this was an irrational number. You'll notice on your calculator that it keeps going past that 0. But there were no patterns. It's not like 0.3 repeating, which is 1/3 or something like that, where you have like a repetition. That's what rational will look like, okay? Last one has a nice little fraction. We have the square root of 25 over 64. When you have a fraction like this, what you're really doing is you're taking the square root of the numerator and the square root of the denominator, just doing them separately, okay? So the square root of 25 is 5. The square root of 64 is 8. So the square root of 25 over 64 is 5/8. That's a nice pretty fraction. That was a rational answer. All right, what about the other roots? We just did a bunch of square roots, but there's other types of roots too, right? So we have other roots. So just reminding you guys, the opposite of cube rooting is cubing. and versus other powers as well. So with that nth root, whatever that root is, sometimes you're going to have, a 3 there for a cube root, or a 4 there for a fourth root, or even a 5 there for a fifth root. You can have any number there in that index spot where the n is. That nth root of a equals b, then that means that we're looking for some b to the n to equal the a. In general, if you guys notice that if we had a square root of a negative, that gave us an imaginary number, because that negative times a negative equals a positive, or a positive times positive equals a positive. That's going to keep going with any even root. So any even root of a negative number, we're going to get an imaginary for the same reason as we did for the square root. Now, if you have an odd root, though, well, if you have like 3 negatives multiplied together, you'll get a negative answer. So you can actually get negatives just fine with odd roots, like a cube root or a fifth root. That result would just be a negative number. So let's do some other roots, okay? In example 2, we're just going to find the root, and if it happens to be irrational, not real, we're just going to say that it's irrational or not real, okay? So the first one I've got is the cube root of 8. So what you're thinking is, what raised to the third power equals 8? That's what you're thinking about for this. Well, I know that 2 to the third is 8. 2 times 2 times 2 gives me 8. So the answer for the cube root of 8, that root would equal 2. Okay? What about the fourth root of negative 16? Well, this is an even root. So that means that I'm going to have the same number multiplied 4 times, by itself 4 times to get a negative answer. That's just not going to work, okay? Because even if you had a negative all 4 times, a negative times a negative is a positive, and times a negative would give you a negative, and times another negative would give you a positive answer, okay? So you're not going to get a negative 16 no matter how hard you try. So this one is not real. All right. What about the fifth root of negative 100? Can we do that one? Well, a negative inside, that's perfectly fine. If you have 5 negatives multiplied together, so a negative number to the fifth would give you a negative result, okay? So that works out just fine. The problem is that 100 isn't anything to the fifth power, and if it helps, I think it helps to break these numbers down. So like 100 is 10 times 10, 10 is 2 times 5, and 10 is 2 times 5. And if you break it down to the prime numbers, we can look for a group of 5, and I don't see a single group where it has 5 the same thing in it. Okay? So this one is not a perfect fifth. So that just means that we're going to have an irrational answer. It'll be a negative number, and it'll be irrational. All right, last one I have is a nice little fraction. And we've got the negative 6th root of 1 over 64. All right, so with fractions, what we're going to be doing is we're going to take the 6th root of the top, and we're going to take the 6th root of the bottom, okay? 1 is a great number because 1 times 1 times 1 times 1 times, any number of 1s gives you 1. So 1 is really, if we want to write that as a group of 6, we can. We could do 6 1s multiplied together would equal 1, right? So we have a group of 6. So that top part, the 6th root of 1 is 1. And the bottom part, let's break that apart. 64 is 8 times 8. And let's see, 8 is 4 times 2, and 4 is 2 times 2. And I can do the same thing again. And when I break it down to all of its prime numbers, I have 1, 2, 3, 4, 5, 6 2s. So the 2s make this beautiful little group of 6 that we can take out. So the 6th root of 64 would be 2. And it was negative all along, so our answer is also negative. So our answer will be negative 1/2. Now it's your turn. You all get to try one and show me how much you've learned.